Now here's our situation. We've got the Iditarod race that goes 1,049 miles total from Anchorage to Nome. Now here's what we're told. A musher is 4 times as far from Anchorage as Nome. So how many miles has the musher completed? Let's draw a picture, kind of a picture of what's happening. Maybe here's Anchorage. Here's Nome. Maybe this is Anchorage. This is Nome. And now we are told that the musher is 4 times as far from Anchorage as from Nome. All right, so the musher started at Anchorage and was going toward Nome, and now the distance is somewhere in here where the musher is 4 times as far as this. Right, we're 4 times as far from Anchorage as Nome. So why don't we do this? Let's just put a mark here and let this distance be x. That will be the distance from where the musher is now to Nome. Now what I'm seeing here is that as I read this part right here, the musher is 4 times as far from Anchorage as Nome. So what's coming second in this sentence is Nome. So I'm going to let x be the distance from Nome. So x will be the distance from Nome. And if this is x, this distance here must be 4x, right? Because the distance from the musher from Anchorage is 4 times that distance from Nome. Now we know this. We know the total distance here from Anchorage to Nome, right? From Anchorage all the way to Nome, we know that that's 1,049. And now, how do we get this total distance? Well, the total distance, right, from here to here is the 4x plus x. So this total distance right here is 4x plus x. That's equal to 1049. This is 5x equals 1049. Divide by 5. And when I did that, I got x equals, okay, I'll write what I'm doing here. I'm going to take the 1049 divided by 5. So I'll bring that up here. So I got x equals, is 209.8. But let's be careful now. Here's the question. How many miles has the musher completed? Well, we got x. Now, x is this. That's the number of miles yet to go. The number of miles completed is the 4x. So what we need to do is multiply by 4. So we'll get 4 times 209.8. And I got 839.2. But let's just round that off. So we'll say that the musher has completed 839 miles. Problem number 2 deals with what we call complementary angles. Complementary angles. And complementary angles are angles whose measures add up to 90 degrees. Let's draw a picture here. So I'm going to draw a 90-degree angle here. So this angle right here is 90 degrees. And if I draw a line through here and make 2 angles, like, okay, here's angle A, here's angle B. Here's what we know. The measure of angle A plus the measure of angle B, this is 90. That's always true for complementary angles. So let's make a drawing for our problem. Here's a right angle, and let's just draw some line in here. So we'll have 2 angles. Now, let's introduce a variable here. Let's look at what we have here. We have one angle measures 24 degrees more than twice the measure of the other. Let's let x be one of the angles, all right? So x is going to be one of the angles. Now this angle up here, if this is x, we do know something about this. These angles here, this one and this one, have to add up to 90 degrees. Now, when I read through here, here's what I see. One angle measures 24 degrees more than, right, there's that more than. We talked about that section ago or two, remember? So more than twice the measure of the other. Okay, so twice the measure of the other. So if this is the other, because we've just label one of them x, then here's where we start, right? Twice the measure of the other. So twice the measure of the other is this one, 2x, and that is going to be, so let's see if we can get this angle here. So if we label this one x, what is this one? Well, let's go up and see. It says this. One angle measures 24 degrees more than, okay, there's that more than, so let's see what comes right after that. That's where we start, remember? More than twice the measure of the other. Okay, so here's the other. That's where we started. Twice this measure is going to be 2x, but we're also told it's 24 more. So we label one angle x, and then the other one, we get just by reading through here, one angle measures 24 degrees more than, there's the more than, what follows more than is where we start, twice the measure of the other. So our x, twice that is 2x, but we have 24 more. And now we know that these two angles are complementary, so if we add their measures, say x plus, and then the 2x plus 24, right, there's one angle, there's the other one, we should get 90 degrees. So x and 2x is 3x plus 24 is 90. Let's subtract the 24. That'll give us 3x equals 66. Divide by 3. We will get x equals 22. Now the question here is we want to find the measure of the smaller angle. So what is x? So let's follow it back. What was x? Well, that was x, and this is going to be the smaller one, right? Because if we double this and add 24, we'll get the bigger angle. So we're not going to write x equals 22 as our answer. We are just going to write 22 degrees. So what's happening here is that we've got two major cities, or two cities, and they're 528 miles apart, and we've got some tourists leaving one city at 39 miles an hour, and another set of tourists, group of tourists, leaving the other city at 49 miles an hour, and they're headed toward each other. We want to know how long is it going to take before they meet. Let's make a drawing here. Here's one city. Here's the other city. Now, I'm going to make a drawing like this. The group leaving this city, say they're going 39 miles an hour. So they're headed this way. They're going to make up a certain distance. And the group leaving this city, well, they're traveling here, right, at 49 miles an hour. So in the same amount of time, they're going to go farther. This group's going farther than this group. Now, here's a fact that we need to know. We need to know that distance is equal to rate times time. So the distance one travels depends on how fast it's traveling and the amount of time that has elapsed. So maybe I'll do this. When they meet, I'm going to put a line here to indicate where they meet. Now I'm going to put it on toward this side over here because this group's traveling at 39 miles an hour. This one's 49 miles an hour. So this group's going to go farther. So we have this distance here going to be a little bit less than this one here. Now, how about if I call this one distance 1 and this one distance 2? And here's one thing we know about those two distances. Distance 1 plus distance 2, that's the total miles between the two cities. That's 528. Now, distance 1 is, well, distance is rate times time. So the rate is 39, and the time, well, we don't know. So that's going to be 39 times the amount of time, 39t, plus, and this distance here, well, again, distance is rate times time, and this rate is 49, so we're going to have 49t, and that's got to be 528. So there's our equation. Let's add those together. 39 t's and 49 t's is 88 t's equals 528. We're going to divide by 88, and that will give us that t is equal to 6. So what we're going to say then is, how long does it take? It takes 6 hours. Right? We're not going to write it as t equals 6. We're going to write 6 hours. In problem 4, we again are going to use this distance formula. We've got two truck drivers leave a cafe at the same time, but they're traveling in opposite directions. Let's get a picture of what's going on here. Here's the cafe maybe. One truck goes this way, and the other truck's going this way, right? Opposite directions. And then we're told that one truck goes 2 miles an hour faster than the other truck. So why don't we introduce a variable here? One truck goes 2 miles an hour faster than the other truck. So when I read this, I've got one truck and then the other truck. The way I typically set these up is that whatever comes second, right, faster than, there's the word than, so what comes second, that's what I'm going to let the variable be. So how about if we let r equal, now I'm going to put it over here because this one is going slower than this one. So this one, if that's r, this one over here must be r plus 2, right? 2 miles an hour more. Now again, we're going to use this idea that distance is equal to rate times time. So what distance has this truck traveled? Well, that rate times the amount of time. So what we're going to have is, if we call this distance 1 and this one distance 2, we know that distance 1 plus distance 2 is equal to 168. And distance 1, that's going to be this distance here. It's going to be rate times the time. Now the rate is r, so we're going to have r, and the time is 2, right? We've gone for 2 hours, plus, now this distance here is going to be the rate, which is r plus 2. Let's get that, r plus 2 times the time, 2, and that's equal to 168. So let's just rewrite this. This will be 2r plus, now I'm going to multiply through here. I'll get a 2r plus 4 equals 168. Add those together. We'll get 4r plus 4, 168. Let's subtract that 4. So we'll get 4r equals 164. Divide by 4. That'll give us r equals 4 into 16 is 4. 4 into 4 is 1, so we'll get r is 41. But now in word problems, you got to take a look back what r is. We got r equals 41. Now, taking a look back here, what is r? Well, r is this distance of the slower truck. So we also have this distance here. So the faster truck is going to be r plus 2. We've got r right here. So 41 plus 2 is 43. So let's just say what we have. Let's summarize. The slower truck is traveling at 41 miles per hour. The faster truck at 43 miles per hour. Number 5. This is a mixture problem. And I always set these up as if they were chemistry problems with mixing beakers together. So what I'm going to do here is this. I noticed that we have a dark chocolate and then we have a white chocolate. So I'm going to draw these as beakers, as if we're mixing one thing with another. So I'm going to say we have a beaker here, and if we mix them together, this is going to be a result. So we'll have some in here, some in here. We add this over here to this, and we get this. So I'm going to set up all these mixture problems this way with these beakers. Now, what I'm going to do is I'm going to put the amount inside, seems reasonable, and then the percentage on the outside. This is a description of what goes inside. So what we want to know is this. How many kilograms of dark chocolate? So maybe this is a dark chocolate. We're going to mix that with the white chocolate. So we don't know. So why don't we let that be X? We have X kilograms there, and what we do know is that we are going to take this X, put it in here, and how much is in here? Well, according to this, it should be 200 kilograms. So this is going to be 200. And now if we add these together, if we take this, add it to this, it tells you right here, right? X plus 200. Like if this was 50 and we add it to 200, we would have altogether 250. But this is X, so we're going to have X plus 200. So over here, our total amount will be X plus 200. And now we know this. this dark chocolate here is, according to the instructions, 31% fat. So this right here is going to be a 0.31. 31% is fat. This one over here is 37%. So this is going to be 37. And our result, the result has to be 36. Now, this equation is really right here in front of us. This one here is 31% fat. So it means 31% of its multiplication of this amount is fat. So there's our equation, 0.31 of this. So I'm going to write 0.31x plus, this one here is 37% fat, so it's 0.37 of this. So it's 0.37 times 200 equals, and now this one here is 36% of this is fat, so 0.36 of times this. 0.36 times x plus 200, and there's our equation. So let's see what we have here. This is going to give us 0.31x plus, now 0.37 times 200, my calculator shows that to be 74, equals, now distributive property right here. So we're going to get 0.36x plus, and then it's going to be 0.36 times 200. 0.36 times 200 turns out to be 72. Now here's an equation with x's on both sides. And the way I like to set it up is I like to get the side, x's on the side of which I already have more. I have more here than over here. So let's subtract these. So the plan is to subtract that 0.31x, and doing so will leave us with 74 equals, now 36 minus 31 is 5, so 0.05x plus 72. Let's subtract that 72. So 74 minus 72 is 2 equals 0.05x. If we divide by 0.05, we will get x equals 40. Now, what is x? It's a word problem, so follow it all the way back. What is x? So following it all the way back, x is, well, x is the amount of dark chocolate. So here's the question. How many kilograms of dark chocolate should be mixed with the 200? Well, we got it. It's 40. So let's just write it as 40 kgs. Number 6 is another mixture problem. So I'm going to set this up right away by drawing a beaker plus a beaker. We'll mix those two minoxidil solutions and get a resulting minoxidil. So we'll have some here, and you add them together, you get a little bit more. We're going to take this one here and add it to this one here. Now let's take a look at what's happening here. The pharmacist wishes to mix a solution that's 6% minoxidil. So we know that we want the resulting mixture to be 6%. So we can write that down. We want this to be 6%. We already have some 3%, so maybe we make this 3%, and if we make this 8%, then it looks like what we're going to do is we're going to add the 8% to the 3%. And the question here at the end is, how much of the 8% solution should she add? So how much of this should she add? So we don't know. Let it be x. And we know how much of the 3%? We're told that we've got 90 milliliters of that, right? There's 90 milliliters of the 3%. And then if we add these together, x plus 90, how much is going to result? X plus 90. And now we have a problem, a setup that looks just like the one in number 5. So we're going to have, here's our equation, 0.08x plus 0.03 times 90 plus 0.0, not plus, let's get rid of that plus and make that an equal 0.06 times x plus 90. So this take is at 0.08x plus, now 0.03 times 90, I got 2.7. equals, and distributing, we'll get 0.06x plus, now 0.06 times 90, that's 5.4. Now, we have an equation that has x's on both sides. Here and here, I've got more over here, so I think a good plan would be to subtract 0.06x, right? That one. So doing so is going to give us this. 0.08 minus 0.06 is 0.02x plus 2.7 equals 5.4. Let's subtract that 2.7. So we'll get 0.02x equals, now 5.4 minus 2.7 is another 2.7. And now we are going to divide by 0.02. So we're going to get x equals 2.7 divided by 0.02. And I'm getting 135. So we're going to conclude now that we need to add 135 milliliters of that 8% solution. So we've got a baseball team paying its ace pitcher 5 times as much as they paid their shortstop. So here's what we know already. They paid $12 million altogether. So the total that we've got here is $12 million. You know what? I think I'll just write that down so I have that. The total is 12 million. We'll do everything in millions. Now I'm going to introduce a variable here. I'm going to say let x equal, now we have two things going on here, right? We have the amount of money we're going to pay the ace pitcher and the amount of money we're going to pay the shortstop. Now which one do I let x equal? Well, when I look at this, it says the team paid its ace pitcher 5 times as much as they paid their shortstop. Now this usually works, not all the time, but almost all the time, is I'm going to let x equal the one that comes second. This one, the pitcher, is in terms of the shortstop. So if I let x equal the amount of money paid to the shortstop, I can get the pitcher. So I'm going to start here by saying let x equal the amount of money paid to the shortstop. Now we also need the amount of money paid to the pitcher. So I'm going to have something here is equal to the pitcher. So we're going to have, if I let x be the amount of money paid to the shortstop, then I still need the amount of money paid to the pitcher. So what's that going to be here? Well, here's what it says. The amount to the pitcher is 5 times as much as the shortstop. So if x is a shortstop, 5 times that is 5x. And now I know that the total is $12 million, but I get the total by adding the individual salaries. So we're going to get x plus 5x equals 12 million. 6x equals 12 million. Divide by 6, we'll get x equals 2. But now it's a word problem, so take a look at x, follow it all the way back. What is x? X is the amount of money paid to the shortstop. So we still have this one. How much to the pitcher? Well, it's 5x. It's right down below it, so write it right here. So 5x equals, and there's x right there. We get 5 times 2 is 10. So the shortstop salary turns out to be 2 million, and the pitcher's salary turns out to be 5 times that, 10 million.